get started. Hi, my name is Hamza. I come to these meetings every time I can, and it's cool to speak at them finally. A huge thanks to Evan, Emily, Vlad, everyone else at PMG. Thank you so much. So a little bit about me. I'm a data scientist by title, lead AI engineer by function. I kind of got a head start on AI before it kind of took off. And as a result, I was ready to implement things once it took off at my company. I'm currently designing patent pending products for Velocity Global, and I'm also doing some research with LLMs, hoping to publish a paper in the next 2 months. And if this goes well, hopefully I can be back to speak about my paper. Okay, so let's get started with this long block of code. You can't really see much of it. So I have a picture, so you can kind of zoom in. So this is an Airflow DAG. Actually, let me ask really quick. How many of you guys are like finger to keyboard devs? Like you code for your job? 1, 2, 3, 4, 5. Okay, so majority is non-technical users. That's good. That I know that now, so I can't spend as much time on the code. But okay, so basically what this thing does is it runs according to a scheduled cadence. And when you write it, it'll run, as you can see here, here's this parameter, time delta days equal 1, it'll run daily. And what it's going to do is it'll go to your knowledge base. I use Wikipedia here as an example. And it's going to grab the text there, and it's going to update the embeddings in your database so you can have the most updated data at any given time. And this is really important for things that change. I work for Velocity Global. They have a lot of regulatory and compliance data that needs to be up to date, and we need to be able to capture those changes as they happen, because if we use the wrong data or knowledge to inform our customers, perform some action on behalf of our customers, that's really, really bad. Back to the slide. So yeah, this is kind of what everybody knows when they first get into AI engineering. You schedule a job to grab the latest data from your sources, you chunk everything, and you re-embed everything, and you update your vector store. So I did a quick demo here to kind of showcase that. Praying to the collab gods, it's known to mess up quite a few demos. But once this pip installs, I'm going to go here, and I'm going to execute basically what you saw earlier in the DAG, but just the code itself. It's just fetching the Wikipedia page, or this is representative of what your knowledge base would be, and it's going to update the embeddings. Yeah. And I would have done this earlier, but it's known a timeout and make me do this again. So cool. Now that we're almost close to installing all of our packages, should have run my code down here. And it's running it right now. And the point is, you can do this. It's a way to update your data and have it up to date, but there's some caveats to it. Here we see it printing out the entire Wikipedia article just to see what we grabbed, and it's going to create our embeddings here. But this is a very, very wrong way to do things. Your processing and embedding costs scale with your refresh frequency, and it's detrimental to both the processing power that you use, that you want to save because your time or your build based on the time that you spend doing that, And also you want to hold on to costs as much as possible in this phase and really just stretch out your AI allocation budget to try as many things as you can so you come out with something successful as a company. So the better way to do that is you use a scheduled job to grab the latest data from your sources, and you create a short and unique representation of it. You want to use some sort of encoding algorithm to do this. My algorithm of choice is SHA-256. It's the same cryptographic hash function that encrypts Bitcoin. So as long as Bitcoin's price isn't zero, your data is safe. And only when the data changes do you need to update your embeddings. You save lots of costs, and it's optimized for time and processing. And then we'll look at a quick demo of that. Okay, cool. This is the first time we're running it, so there's no such file or directory for the hash. And we see new content was detected, so we were going to update our embeddings. And that's awesome. Let's try to do that again and see what happens. We can see that the content didn't change. No updates were made. Works as expected. And then let's go ahead and change our content and see what happens. And then we detected new content and it changed. We'll do that again. New content detected. And we just saved the document checksum there. Okay, so as you save your data, you're actually just saving a representation of it, and that kind of increases your savings also, because now you're not saving a large corpus. Some of these corpi can go up to like over 1 million tokens, multi-million tokens, things like that. You don't want to store that all in one place, and especially if it's sensitive data and say there's a breach, well, they'd have to crack Bitcoin's hashing algorithm before they can get to your data. Okay, so this talk was supposed to be 20 minutes. I'm a very to the point person, but I thought I could add some extra knowledge and capabilities. So today I will be focusing on this entire half of RAG, which is retrieval augmented generation. Speaking which, I probably should have asked, or I probably should have presented this earlier. I thought there'd be way more devs, but this is kind of basically how it works is you take your documents, you chunk them so they can be retrieved when you're running your LLM system, and you store them in the vector database. When your end user prompts something to a chatbot or one of your products, your system goes back to your vector database to grab your knowledge, puts it into your prompt, and gives it to the LLM to get the result. But yeah, so a little bit extra knowledge on Embed. Okay, so our AI devs here know this. You take your corpus and you run your LangChain recursive character text splitter, but there's a slight problem with that. You have a serious problem with your RAG application 99 times out of 100 because your chunks are usually incomplete. You risk the chunk with your actual data to not be the highest strength embedding when retrieved, if at all, in a scenario where the LM isn't guaranteed to predict the correct answer. So let's take a look at, no, I'll come back. So this is, how we would do it. We would grab our Wikipedia page. To split it, we would use a naive recursive character text splitter, and it would split our text. However, if you look at our chunks, you see that they're very fragmented. They don't contain the full context, and they're cut off. So say one of these chunks belongs to the entire chunk or the entire piece of knowledge you need, the entire piece of context that you need. and it doesn't get that chunk, it's not going to be able to correctly answer what the end user needs. And that can be very, very bad. Why? Well, besides the fact that you won't have your entire context in your prompt because your RAG is inefficient, there's a general problem where there's a loss in the middle problem. Basically, this is saying, or this was found or discovered with LLMs and RAG systems, that chunks that appear in the middle of your prompt. So, for example, a prompt system, user asks the question, we take that query, we go to our vector database, and we try to retrieve the chunks that we need. But what if one of the important chunks is in the middle? It's found that LLMs are actually not good at answering questions or even paying attention to chunks that are in the middle. So this brings a dire need or requirement for RAG systems to have the chunks ranked at the very top. And there's a paper here. You can go ahead and read it. Most people, including myself, hate papers, though I do read them all the time. But we have a very nice TLDR here. So as you can see, we have 20 total retrieved documents. And as the position, you don't want to go over retrieving more than 5 chunks. But even if it's not the first and it's the 5th, your accuracy heavily drops. And this is APT 3.5 Turbo. We have better LLMs now, but the problem still persists. And we also see that you want to minimize, we're engineers, we try to think, oh, what if we just include more chunks? No, bad approach. More chunks equals more confusion equals bad answers. So this is super crucial. If your retrieval accuracy is anything less than 100%, you might hallucinate and misinform your end user. The cost of relaying the incorrect info to your customer in the real world can be paramount because, say, you work in compliance or a regulatory company like I do, and your biggest client takes action based on an incorrect response or internal user that processes things based off your knowledge base, gets an incorrect response and acts on it, they might just go to your biggest competitor. But don't fret, you can always find some sort of pattern in any knowledge base. So find that and chunk on that. And then you have chunks that contain all the information for a given subtopic with an increased chance of the correct chunk of information being at the top of your retrieval. And this is kind of how you would approach it. Let's go up here. Yeah. So this is what the naive chunker attempted to chunk for us. We see that, it's a bunch of text, it's a bunch of text, it's a bunch of text. But any of my devs, can you notice some sort of pattern that maybe we can chunk on? Any hands? I'm sorry? Yeah, exactly. Very good. So as he saw right away, there is some sort of structure in this unstructured data that you can chunk upon. So now that we see that, we can come up with some regex expression to split upon, excuse me, to split upon it. And this happens to be that regex expression. And if we use that to split instead, we see that we have entire chunks, no cutoff, all the data is there. And now we have a much higher chance of having our exact chunk of information that contains the answer to some end user to be ranked at the very top and therefore maximize our prediction or accuracy. And we can actually go one step further. So naive chunking, we can see that we want to chunk this. We end up chunking it, and then we see that there's some cutoff, and our approach with the regex expression kind of took care of that. So now we have subheading with the text, but we can go a step further and just grab the parent heading and its subtext and prefix it to our chunks. So we know the overall subject, we know the actual knowledge that we need, and we can further maximize our chances of having 100% retrieval accuracy. And some bonus learnings over the year. Text embedding 3 large is by far the best embedding model that we've tested. Cosine similarity retrieval is more performant and faster in 99% of cases. You can use other measures like Euclidean distance, but they're just not as good. Hybrid retrieval is actually the most accurate, but it ends up taking 30 seconds to a minute, which is detrimental to the user experience, where they kind of don't want to wait more than 10 seconds. So in those cases, you want to use cosine similarity, but you can test the type of hybrid retrieval that would work best for your system, and then implement that for things like document processing, et cetera. Re-ranking is also an excellent way for combating the loss in the middle problem. Cohere offers an out-of-the-box solution that's as easy as using some Python library. So definitely implement that. And actually, let's go back to change management. So there is one further step. I can't include code for this because I'm currently working on this for my company, but I can talk a little bit about best ways to do it. So refreshing your data with update alerts and a human in the loop. So say you are using some sort of source to grab the data, and you want to make sure that if anything ever changes, the data that you extract from it is current and complete. You can set it up such that there's a DAG that grabs those scrape changes and stores them into an approval. This is going to sound whack to my devs, but yes, in a G sheet, the best way to have your non-technical users interface with your technical system is to work with something in their domain. So yeah, write to a G sheet. It's still a table at the end of the day, and you can detect the changes with that hash-based change detection system and update some sort of approval column to pending approval. Until they approve it, your downstream DAG that reads all the rows that are approved or all the rows that are unchanged won't pick up the new information until it's been approved by someone, say, on a knowledge team. And you can also set up Slack alerts. So if raw scrape changes happen, that lets you know, hey, let me go in and see if the web scraping script that I set up still works for this page if they change something like the HTML tags, for example, and the data isn't in that exact tag that I web scrape from. You can also do similarly to set up Slack alerts for your business team. So as soon as something goes into pending approval, they know to check it, they're prompted for it, and they can just go into that table. And then once they mark it approved, you can have your DAG come in, see that it's approved, and then extract the new changes, and then push them to your vector database, keeping your rack system up to date and minimized liability. But yeah, that's about it. That QR code goes to my LinkedIn. Please scan it. Please add me. And yeah, I'd love to answer any questions that you have for any AI engineering things that you might be working on, or if you just want to pick my brain, or you just want to network, but more than happy to do it. And just a quick plug, I'm looking for a co-founder, software engineer that knows on the JS and TypeScript side with some AWS background. I'm really good with Python and data science and AWS, but I do lack there. And yeah, I'm currently working on a website, and would love to find a co-founder for that. And that's my talk. Thank you guys so much.
Hi, my name is Sunil. Thank you for the talk. I mean, it's so simple. Calculate a one-way hash, compare, and only update if there's actually a change. Of course, I mean, you can actually look at other stuff like metadata on top of files to see if something is modified and all that stuff. But thank you very much for this. I'm kind of curious. We use Cohere, and I can tell you that, like you said, if the context is very large, the accuracy actually goes down. And we use re-ranking. I mean, when we don't do re-ranking, the accuracy is about like 60%. And when we re-rank, it goes to about like 95%.
It's a huge difference.
It's incredible, but I never understood why there's nothing similar on OpenAI or Anthropic side, right? There are open source re-ranking models, but nothing in the proprietary cases. I'm kind of curious. It's something that I came to know just this morning, and I asked my team to look into it. I'm kind of curious if you kind of spend some time to look into the re-ranking aspect.
Yeah, so I guess the question was, why don't LLM vendors include re-ranking? So one thing that would have to happen for that is they would either have to host a vector database for you, which a lot of companies don't want their data out there to be ready to be breached, but they're okay with it passing through an API. And another reason is if they were to do that, their latency would go way up, so they probably don't want that on their side as well. I think those two are the main big ones why they don't want to do it, is they just want, hey, ask me a question with some information provided and I'll give you your answer, but all this other focus can be abstracted away to some of these startups. I agree, it's a very powerful tool, but it's some mix of we don't want to do it because our inference latency is going to go up, and then honestly, companies just don't trust their data in anybody else's hands.
Thank you. Hi, Jason Karpoulos. I have a question about hierarchical RAG. Have you heard of that before?
I may have, but I don't recall exactly. If you can please.
Where you progressively start with small chunks and then you use larger chunks and you feed or inject the actual chunks small, larger, larger, so that it knows the context.
Mhm.
I wonder if you have any experience with that.
Yeah, so I haven't approached RAG systems with that approach. And right away, I can just think of the loss in the middle problem, where you don't want ascending by size to affect your chunk ranking. You always want the most pertinent chunk ranked at the very top for maximum accuracy. Of course.
Hi, I'm Sylvia. I would like to know what was your process to find the best hash and the best stack splitter?
Yeah, so as far as testing. Okay. Yeah. So finding the best hashing algorithm, really, it's up to you. If you want to minimize for processing or for time, you can go with that. I personally just love Bitcoin, and I love how secure it is. So it's reliable, and it ends up not being too process intensive. So that's why I chose it. But there's a plethora of other encoding algorithms that encode even more securely than Bitcoin that you can go with, or SHA-256 rather, I should say. So yeah, you can choose that. And I'm sorry, what was your second question?
Yeah.
Text splitter. Okay, yeah. So there's no consistent text splitting mechanism. You kind of just have to have experience dealing with documents and kind of finding the pattern. Once you do it a couple of times, it becomes very easy, just like everything else. But as the gentleman over there saw, each heading and subheading, if there's some sort of pattern that you can use around it, you should do that. They don't always come with that. So a couple of advanced techniques you can do is PDFs are often able to be converted into HTML, and the headings will have a specific type of tag. So you can hone in on that specific type of tag and say, use this in my regex expression and find that tag to be the heading and kind of go from there. Another approach I was thinking of the other day, I haven't implemented this as of yet, but you could do something like heading size versus text size and see the distributions within them. And if you're lucky enough, the ranges don't overlap. Your text is usually much bigger and your heading length is much shorter. So you can say, hey, if it's less than n amount of characters, it's a heading. If it's more than n amount of characters, it's text. So you can use that as a splitter, but yeah, it all just comes down to really at the end of the day, the unstructured data that you're working with.
Yeah, the chunking you talk about is primarily related to unstructured documents. And I wonder if you have experimented with any of those structured data source, like your relational databases, and when you try to pull those data,
Yeah, so
I wonder what type of chunking techniques or embedding technique you use with those type of data.
So generally with structured data, you don't want to do anything like chunking. What you want to do is have some sort of input parameters that calculate the query to your database. So say on the front end, you have the user select things like country, age, location, whatever random inputs that you require to grab the specific data from your database. You have them input that. Your script queries your database for that exact data, and then you can inject that into your prompt to output some. That's kind of like the best method I've found to work with structured data and kind of minimize it to what you need to. And you kind of get away from chunking, which is nice.
All right, we'll do one last question. Yeah, continuing to what he asked, right? How do you do the streaming data, right? Is it possible to use some of these techniques with the streaming data?
What kind of stream data?
Let's say metadata, like, we have a huge volume of metadata ingestion.
Okay.
We were thinking to do some of the questions against that, right? Is it possible to do some chunking? I mean, put it in this kind of retrieval.
Yeah, I mean, as long as you can store each piece of stream data somewhere, it should be doable. You can store it into a table based off of metadata tags, for example. And you can also do things like just have them in like a full document. And yeah, again, I would have to know the exact shape of the metadata that you're working with. But yeah, if it's in some sort of document and you separate metadata by event, then you can chunk based off that. And then now you have your isolated metadata that you're retrieving based off the similarity to your input query.
And with these vector databases, would you be able to remove some of the data from that?
Yeah, definitely. LangChain gives you both the ability to delete certain rows in your collection, and it also gives you the ability to update the collection fully. So say you delete some metadata, you can create your embeddings anew from like the entirety now that the metadata is gone.
Okay. All right, then with that, we'll do one more question. He looked like he had a good one, so.
So
pre-existing models.
Yeah, so fine-tuning a model is possible to a certain extent, but I found the best ways to improve your LLM accuracy is really just maximize your retrieval accuracy. So you focus on your vector database and then kind of tuning your prompt based on a test set. So say you have a set of queries that Knowledge came up with saying, hey, we need to answer this. You just make sure that your prompting system answers those questions. And if it doesn't, then you just fine tune your prompt and until you iterate towards maximizing your accuracy.
All right, and with that, everybody thank Hamza for his talk and sharing his knowledge with us. We appreciate you. All right, and with that, we're just about done, but before we head out the door, well, actually, we'll do a little bit of networking. There's plenty of folks here to meet and chat.